Okay, you just wanted to double check
Yes.
your equations?
So for number 7, 17. Easy. Okay. So these two, I guess these two I needed to switch because a lot of people got this one here. I added a few drops of this. Says, I guess we should start with number C. So for number C, for this one right here, we added, let's see, what did we do?
So I'm just reading over your shoulder.
Okay.
So for this guy, and we're saying this is number 6, letter C. Are we saying this one or this one? Because you have an arrow saying you need to switch it.
Right. I believe it's the MG that we're referring to.
So the 2 test tubes containing precipitates, what are those 2 precipitates? I know that we have,
It's MG.
is it Mg, is it calcium and magnesium? Those are the 2 left? Okay. So now in both of the test tubes, you dissolve 6 molar HCl, right? So you want the precipitate to disappear. So in other words, it's becoming an ion again, right? Hence it's not a precipitate anymore. So, okay, then add 6 molar of NH3, a drop at a time until the solution is either slightly basic, will change red litmus paper blue, and smells of ammonia, or a precipitate forms. If a precipitate forms before it is slightly basic, that is okay. Simply add 1 molar HCl dropwise, stirring until the precipitate just dissolves. Blah, 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 blah. Then add 1 drop of 0.25 molar NH4,2C2O4 to each test tube. One of the test tubes should be formed precipitate. Okay, so one of them formed a precipitate. Do you remember which one?
It was the C8. I already switched it, so this is right.
Oh, so we have Ca2 plus this makes this and this. So was the purpose of adding the NH3 to make it basic, just very slightly?
I think so.
It makes sense because you were trying to get it to turn blue. If a precipitate forms before it is slightly basic, that is okay, simply add dropwise until with stirring into the precipitate system. Okay, yeah, so you just want it slightly basic or maybe a little neutral. Then we're adding this guy. And a precipitate forms. H4,2C2O4. Okay, so this guy breaks apart, and it looks like the NH4 probably either becomes NH3. No, that wouldn't make sense. It could. And then the NH3 grabs on, but that wouldn't make sense either. So do you have your old lab with all of your, do you remember the lab that you had all of your tests on from virtual lab?
Yeah, but I don't have that with me.
Because that's how you're supposed to use that as your, you probably did it that way, right? Did you use that as your reference?
No.
Because that's your reference point.
Okay.
Because a lot of times it's not necessarily forming something like this. It could be something that's different than that just from looking at it. You need to use that thing I guess that whole chart that you gathered from virtual lab where you did all of those different experiments. You started out with this and you added this, what happened? You took note of it. So that's how you're supposed to follow this. But I don't know in virtual lab if you add an H4 too. But if you add NH4 to the solution, it's an acid. It will either because I'm not sure if this is right, because I have to have that reference.
Okay, and I don't even have that reference either. I don't even know what I did with that.
Well, because you have calcium 2+, but then you have OH2 here kind of randomly. What's that guy doing? Because if you have, you're trying to have no precipitate, but have it be either neutral or basic, slightly basic, before you add this guy. So once you add this guy, there's only one of two things that can happen. Either NH4 will react with calcium or magnesium, or C2O4 will. It doesn't make sense that C2O4 would react. So to be honest, I'm not exactly sure what would happen.
Okay, I'll just hold that.
Do you feel comfortable about all these others?
Yeah, I think so.
I mean, it would be good to reference your chart that you have and just
Okay.
double check. Just go through them and just say, okay, well, does this really make sense? Does this make sense? Does this make sense? Is this really what would happen? Because for each of these, there's only going to be one thing reacting. So 1A, for instance, let's look at this. So we add 1 molar of Na2SO4. Write the net equation for the formation of the precipitate in the report. So when you did that, one precipitate formed, right? This first step, only one precipitate formed. And I have no idea which one it was. I don't remember.
That was the...
Barium sulfate one? Okay, so precipitate formed like that. Well, what's this Na2SO4 plus BaNO3
That's, I don't need to worry about that one.
Okay, good. Because I was like, that didn't happen at all. Then this next one, B, you added an AOH this time. Then this time there was 2 things, actually no, 4 things that happened, it looked like. Is that what that's supposed to mean? B. 4 things happened.
Mm-hmm.
We have 2 precipitates forming, right? And then 2 complex ions.
Mm-hmm.
It looks like you have that correct. It's just making sure that it really is. Because you look at that and go, oh, well, Xenon has a 2+ charge. But that wouldn't, actually this wouldn't make sense. Because that would form a solid, actually. ZnOH2, you would need to have like ZnOH4 2+ or something, or 2-, or... and same with this one. You're looking at this and saying, oh, it has a 3+ charge, so we need 3 OHs,
So
right?
this one, is this...
Oh, there we go. That looks better.
This one?
Well, it could do that, but, oh, thank you, honey. It could do that, but that's the thing, I haven't memorized what happens when you add an AOH. You need to refer to your complex ion charts that you made up with Virtual Lab. Then you can better approach these. But, just to give you confidence, you have the right idea. I mean, this is great. It's just making sure that they actually are right, instead of just kind of doing it. Because if you didn't have that whole entire chart, then you would approach it this way. But then that would be really unfair, because it's not like you know how to approach every single one of those, you know?
I will watch that. I'll watch that.
What other questions do you have on that, though?
Right now, and then we're just trying. Then it would just be figuring out which precipitates formed here.
Oh, good.
Which
Yeah, all you're doing now is just doing a scheme.
following of all this.
Yeah, pretty much. You're just saying, okay, this is what happens every single time. This is the reaction that takes place. I know this because of my experience in the past from doing Virtual Lab and knowing what forms when I add what. Then this is the exact scheme that you follow, that you followed as you were doing the whole entire procedure. You started out with this, you added that, that came out. But it wasn't just Ba+ though, it formed something. It was BaSO4, right?
Okay, yeah.
And it's not, we have plus SO4, you gotta get rid of that. So then that's that first step. You just successfully separated BaSO4. Now you have 4 more you gotta try and separate. Then you did the next step. 2 things happened.
NaOH.
2 things formed. 1, 2 of them are over here if you want, and then 2 of them are over here. But most likely, you'll have to choose which side, because obviously this is catered towards.
This is C.
Oh, it's giving you ABC. Oh, that's nice. Oh, you put C over here, and then you put probably the complex ions on this side.